permutations, factorials, permutations. So second part of day 1. Here we go. We're going to talk now about permutations more. So factorials, again, that's where you start with the number, go all the way down to 1. You're figuring out how many different arrangements you can have. So now the question is kind of like, you know how we had like 6 friends with 4 lanes or 10 friends with 6 lanes? If you're arranging less things than you have, like when we had the 10 runners and the 4 lanes, how many arrangements of those runners can be made? Well, again, we start with our 10. So we have 4 lanes, 1, 2, 3, 4. We have the 10. Then 9 runners can be chosen, then 8, then 7. Again, notice this is not a full factorial. It's only a partial factorial. But I can still determine how many runners or how many different arrangements I have by just multiplying them together. Again, using that fundamental counting principle. So 10 times 9 is 90. 90 times 8 would be 720. And then 7 times 720, so 0. 7 times 2, if you remember, was 4. Bring up to 1, that gives us the 5,040. So there's 5,040 different ways for 10 runners and 4 lanes. What if you have 15 runners and only 3 lanes? So we have 15 runners, so 1, 2, 3 lanes. 15 runners can go here, then 14, then 13. Woo! These are big numbers here. I would probably tell you now mental math is, for me, I'm going to come to my calculator. I take 15 times 14 times 13, and I get 2,730. That shouldn't have been so bad. But, man, it just kind of scared me with all those weird numbers there. 2,730. So, what's happening here? Again, it's not a full factorial, right? It's not a full factorial. The question is, can we come up with some kind of equation again? Well, we do know that if there are n numbers, so we have n numbers in the race, n's going to go here, then we're going to go 1 less, then we're going to go 1 less than that, and then, of course, 1 less than that. The question is, where do we stop? And you might go, oh, you just stopped, here we had 3 lanes. Do I put, if this was 3, do I put a 3 here? And the answer is no, I put a 13 because I was only 3 less than that. So, how did I get from 15 to 13 though? That's kind of an interesting dilemma for us, right? Like how do we get there? Well, there were, if I took, because I can't just take 15 minus 3. 15 minus 3 is 12. But from 12, how do I get back up to 13? Well, I added 1. That's interesting. So if I'm at 10 and I have 4 lanes, so 10 minus 4 is 6, but I don't want a 6. I actually want to end at 7. So I add 1. So in other words, we can get this permutation, this partial factorial by starting out n minus 1, n minus 2, all the way down to n minus r plus 1. And it kind of sounds kind of weird, and it seems kind of weird, but it's true. This is n minus r plus 1. That's what we have to do, n minus r plus 1. That gives you that r right there. Now, there is another way to look at this there is another way to write permutation, and I'm actually going to just write it up for you here. There's another way, and if you're, I'm okay with either way, but if you're in Mrs. Lyons, Mrs. Summers' class, you might want to check with them and verify and make sure that they're okay with you writing this other way. But there are 2 different ways. So we did say that this is a partial factorial. Well, the reason it's a partial factorial is because we're going to take n factorial, and we're going to divide out n minus r factorial. So this is another way to write permutations. You can write it this way as well, n factorial over n minus r factorial, because since it's a partial factorial, you know that you're dividing it out. So To be honest with you, in my personal opinion, it's so much easier though when looking at permutations, and we signify with a P for permutations. So this tells us we have 5. This is our N. This is our number of items we have. And 2 is our R, which I also kind of look at it as our number of lanes or slots. So in other words, I have 2 lanes, and I have 5 runners that are going to go into it, 5 and 4, so that is 20. Again, 7 is the N, number of people we have doing whatever, number of items. And 3 is our R, which would be our number of slots or lanes. So 1, 2, 3, start at 7, 6, 5. Remember, it's a partial factorial. We could get there doing the same idea here. And we know that 7 minus 3 is 4. 4 plus 1 is 5, so we go down to 5, and that's where we ended. We could also look at it this way. 7 factorial over 7 minus 3 factorial, which would be 7 times 6 times 5 times 4 factorial over 7 minus 3 is 4 factorial, and that's 765. Either way, we get 765. Now, personally, I'd probably take 5 times 6, which is 30. 30 times 7 is 210. A lot easier to multiply that way. You can multiply and switch them around however is easiest to multiply. Let's take a look at 8 permutation 4. So if I do 8 permutation 4, we get 4 lanes. 1, 2, 3, 4, 8, 7, 6, 5. Start with 8 because that's the N. You work your way down. 8 minus 4 is 4 plus 1 is 5. You work your way down until you get to number 5. Or again, there's 4 slots. 1, 2, 3, 4. 8 times 7 is 56. 6 times 5 is 30. So 30 times 56, 0. 3 times 6 is 8. 1. 3 times 5 is 15 plus 1, 1680. 1,680. What if I have 10 P5? So I have 5 slots. 1, 2, 3, 4, 5. 10, 9, 8, 7, 6. Woo! Well, we do know that, well, shabuga. We know that 8 times 7 times 6 times 5 was the 1680. We don't have the 5 here. But 10 is 5 times 2. I don't know. We could do some crazy stuff. Honestly, at this point in time, I'd probably turn to my calculator because they can get pretty big, right? So let's show. I'm going to show you here. We got 10 times 9 times 8 times 7 times 6. Oops, forgot the 6 times 5. Nope, no 5. Sorry, delete that part. Just down to 6. Pay attention to what's going on here. That's 30,240. There is another way to do this problem. So let's show you. So, depending on your calculator, how new or old it is, when you go to math, and you go back to PRB, notice this number 2 says NPR. That's for a permutation. Click it. Now again, depending on how old your calculator is, even though this is an 84 Silver Plus 8 Silver Edition, it's still an old enough model that it doesn't give me the option to type in N and R right now. So that means N has already been decided, and they put that number as N, and I don't want that. So I'm going to clear this out. Clear it out. Okay, what N I want is I want 10 as my N. So I type in 10, then I go to math, then to PRB, then to number 2, NPR, hit enter, and then type in 5. So again, if your calculator is this kind of old, then you have to type in the number first before you hit the NPR 5, and it'll look like this. Now, some of you have newer calculators. The newer calculators, when you hit NPR, it actually will give you an open box. It'll look something kind of like this. I'll show you. It'll kind of give you an open box right here. It'll say P and then give you another open box right here. Kind of like that log base button sometimes that some of you have. So in this case, you can then type in 10 and then type in 5. Again, depending on how old or new your calculator is. If I hit enter, I better get out 30,240, and I get out 30,240. Sure enough. So that's another way you can do it with your calculator. Let's look at 12P2. Well, that means there's 12, this end is 12, there's 2 lanes or 2 slots. We're going 12 times 11. This one we can do in our head. 12 times 12 is 144, but that's one too many 12, so take off a 12 off 144 and you get 132. So equals 132, or you multiply 12 times 11. I mean, whatever you need to do. 156 P1. So only have one slot. 156 is going in it. That's your answer done. Woo woo! Okay, down here it kind of walks you through again how to do the calculator, and I've already done it. So those are permutations, folks. How do you know if you use a permutation or a factorial? Well, that's going to be my next lesson, my next video, and we're going to do these problems together, and we'll show you. So I'm going to go ahead and quit now, and we'll do those next video. Have a good one. Bye.